Welcome back to WAPSI. So we can move to another interesting section from electrostatics. Okay, so the first question, 4 charges plus q plus 2q plus q and minus 2q are placed at the corners of a square ABCD. So we can draw the square ABCD as, consider this is the square ABCD, and I'm marking this as A, this is B, and this is C, and this is D. Okay, and the plus q at A, and the plus 2q at B, and the plus q at C, and minus 2q at D. Okay, are placed at the corners of a square ABCD respectively. The force on a unit positive charge kept at the center O. So we want to place a unit positive charge. Okay. The force on a unit positive charge kept at the center O. A, B, C, D. So just 1 second, we have to change the position of C and D. A, B, C, D should be continuous. Okay, at the position of C, that is plus q, and at the position of D, that is minus 2q. Okay, and unit positive charge is placed at the center. The force on a unit positive charge, okay, we want to calculate the force, direction of force from A to O. From A to O, it is a repulsive force because plus q and plus q will repulse each other. So this is a repulsive force towards this direction. Okay, and from C to O, that is also a repulsive force because they both are positive. So along this direction, but the magnitude are same from A to O and C to O, so they will mutually cancel each other. So there is no net force along A direction and along C direction from O. Okay, and from O we want to calculate the force towards B and D. Okay, so from O, B is repulsive because O is positive charge and B is positive charge. So from B to O, this is a repulsive force. Okay, and from D to O, that is a attractive force because see, the minus 2q and plus q at the center, minus q will attract the plus q towards. That means that is an attractive force. Okay, that means plus q is attracted towards minus 2q. Okay, that means the plus q will start to move towards minus 2q. So the net force is along from B to D. Okay, along the diagonal BD. So option 4 is the correct answer, along the diagonal BD. Okay, so we can move to the next question. Okay, the second question. An electric dipole with a dipole moment, so P is given as 4 into 10 raised to minus 9 coulomb meter. Okay, is aligned at 30 degree. So theta is 30 degree with the direction uniform. Electric field of magnitude is, electric field is 5 into 10 raised to 4 Newton per coulomb. The magnitude of torque acting on the dipole. So we want to calculate the torque. What is the equation for torque? P cross E. Okay, so which is equal to PE sin theta, and theta is 30 degree, and P, substitute the values, 4 into 10 raised to 9, minus 9 is multiplied by 5 into 10 raised to 4. Okay, 4 into 10 raised to minus 9 is multiplied by 5 into 10 raised to 4 is multiplied by sin 30. Okay, 4 into 5 is 20, and sin 30 is 1 by 2, and 10 raised to minus 5. which is equal to 10 into 10 raised to minus 5, which is equal to 10 raised to minus 4. Okay. So which option is the correct answer? 10 raised to minus 4 Newton meter. Option 3 is the correct answer. Okay. So can we move to the next question? Yes. The third question. A point charge Q is placed at the corner of a cube of side A. So where is the charge? We can place the charge at this corner of magnitude Q. Okay, as shown in the figure. Okay, and Q is placed at E. Okay, so sorry, the Q is already placed. Okay, the Q is already placed at A. Okay, as shown in the figure. What is the electric flux through the phase A, B, C, D? So we want to calculate the flux, that means the lines which is passing through A, B, C, D. So actually, please focus on this area only. So I will draw a charge. This is the charge. Okay, and here we have the charge lines. The lines are spreading 360 degree around. The charge lines are spreading in 360 degree, and see, this is the area which we want to calculate. See, the area is placed perpendicular to the charge. Okay, so there is no field lines is passing through the area. That means in perpendicular to the area. So the flux through this area is 0. Okay. So if the question is like this, if the charge is at E, okay, if the charge is at E, what will be the flux? So we can calculate that too, because in the next year there is a highly chance for asking this question. Okay, so we can calculate that too. A Q is placed at the corner of this cube at E. Okay, then what will be the flux through this area? So according to Gauss law, the total flux through a closed structure is equal to Q by epsilon 0. So I am drawing a cube. This will be a cube of closed structure. Okay, and actually we are placing the charge at this corner. We can place another cube at here. Okay, another cube at here, and another cube at here, and another cube at here. So total I am placing a 4 cubes in the topmost position and 4 cube on the lowermost position. Okay, so actually there is total 8 cubes are placed. Okay, 7 cubes are placed in the surroundings of this charge. Okay, now the entire field lines are crossing the each side. Okay, so here we have an area A, here we have an area A, here we have an area A. So each faces has 4 area. So total how many sides we have? 8 sides we have of this structure. So 8 sides into 4 area. So actually 8 sides. A cube has 1, 2, 3, 4, 6 sides. Actually we have only 6 sides for this structure and 6 sides into 4 area. Totally 24 area. We get a sides of 24 area through the sides, and actually we are only bothered about one of them. Okay, and this area will share equal fragment of field lines. So 1 by 24th of Q by epsilon is the total line passing through this area. So option B is the correct answer. If the question is like this, if the charge is placed at here, actually we have to put how many? Actually we will put a square in the lower position, okay, and the entire flux is passing through actually 1 2 3 4 5 6 7 8 9 10 sides. So 1 by 10 will be the fraction. Okay, by using the position you can calculate the how much is the fraction of area thus we have. Okay, so by calculating the area we can calculate the flux through that area. Okay, so we can move to the next question, the fourth question. The electric field and potential of an electric dipole varies with the distance. So first we need to know what is the equation for a electric field and the potential of a charge, of a single charge. Then we can calculate dipole, quadrupole, octapole, anyone for the dependence. For a quadrupole or a octapole, we can calculate the dependence of a the distance r. Okay, for the first we need to know what is the equation for electric field, force and the potential for a charge. So the equation for force is 1 by 4 pi epsilon 0 q by r square. It is depend upon 1 by r square, and electric field E is 1 by r square. Okay, yes, F by Q is E. Okay, so 1 by r square, and the potential V, how the potential is depend upon 1 by r. Okay, so here only we want to bother about electric field. Okay, so in case of dipole, electric field will change to 1 by r cube, and the potential is changes to 1 by r square, a multiple of r on the denominator. Okay, in case of quadrupole, that means here the plus q and the minus q, here the plus q and the minus q, here the plus q and the minus q. Okay, a dipole, two dipoles are aligned, that is called a quadrupole. In here the electric field is 1 by r raised to 4 and the potential is 1 by r cube. Okay, in case of octapole, plus q minus q plus q minus q plus q minus q plus q minus q. In case of octapole, the electric field is varies 1 by r raised to 5 and the potential is 1 by r raised to 4, just increasing the number of r. Okay, so in here the dipole, the electric field is 1 by r cube and potential is 1 by r square. So option 2 is the correct answer. So this data, you must study this data, this will help you in the exam. So okay, then we can move to the next question. Two tiny spheres carrying charges 1.8 microcoulomb. Okay, q1 is equal to 1.8 microcoulomb and 2.8 microcoulomb are located at 40 centimeter. Okay, q2 is 2.8 microcoulomb. Okay, at located at the distance, total distance is 40 centimeter. The potential at the midpoint of the line joining the two charges is, so we want to calculate the midpoint. We have a total distance of 40 centimeter, so the midpoint is 20 centimeter. Okay, so this is the q1 and this is the q2 and this is the total distance of D is equal to 40 centimeter, and the center point is away from 20 centimeter from here, and this is also 20 centimeter. Okay, so we want to calculate the potential at this point. So what's the equation for potential? V is equal to k q1 by r1. Potential is just nothing but the q1 by r1. So for the first charge it is k q1 by r1, and the second charge it is k q2 by r2. Okay, So, and what is k? K is 1 by 4 pi epsilon 0. What's the value of 1 by 4 pi epsilon 0? That is nothing but 9 into 10 raised to 9. Okay, is multiplied by q1 by r1. What is q1? 1.8 microcoulomb. That means 1.8 into 10 raised to minus 6 divided by r1. What is r1? 20 centimeter. That is 0.2 meter. So 1.8 into 10 raised to minus 8 divided by 0.2 plus the second charge is 2.8. 2.8 into 10 raised to minus 6 is divided by 0.2. Okay, which is equal to 9 into 10 raised to 9 into 1.8 divided by 0.2 is 18 divided by 2, that is 9 into 10 raised to minus 6 plus 2.8 is 28 and 0.2 is 2. So 28 divided by 2 is 14 into 10 raised to minus 6. So 14 plus 9 is 23. So 9 into 10 raised to 9 into 9 plus 14 is 23. 23 into 10 raised to minus 6. So what is 9 into 23? Which is equal to 230 minus 23, which is 207 into 10 raised to 3. That means 2.1 into 10 raised to 5. Okay, approximately 2.1 into or 2.07 into 10 raised to 5. There is no option like that, 2.07 into 10 raised to 3, 10 raised to 5. So we can conclude to that too. The next nearest value is 2.1 into 10 raised to 5. So approximately the accurate value is 2.07 into 10 raised to 5, but we can correct this term to this 0.07 into 0.1. So the correct answer is 2.1 into 10 raised to 5, which is option 4 is the correct answer. 2.1 into 10 raised to 5 volt. Okay, so we can move to the next question, sixth question. A parallel plate capacitor, okay, this is a parallel plate capacitor, is charged by connecting a 2 volt battery across it. So a battery of 2 volt. Okay, it is then disconnected. Okay, it is fully charged, then it is disconnected. Okay, from the battery, and a glass slab is introduced between the plate. Okay, then a glass slab is placed inside it. Which of the following pair of quantities decrease? So they are actually, which of these quantities is getting decreased? So first one is energy stored and capacitance. Actually, what is the equation for capacitance? Epsilon 0 A by D, okay, which is the initial, and when we introducing a dielectric constant, then it is multiplied by a K. So what is mean by that? The capacitance is increasing. So option 1 is incorrect, and capacitance option 2 is incorrect, and charge and potential difference. Okay, actually what happens to the charge? See, initially a charge is distributed in here, and if you are introducing a dielectric constant, nothing will happen to the charge because it is now it is disconnected. Okay, so option 3 is incorrect, and option 4 potential difference, that will decrease because Q is equal to CV. So C is equal to Q by V. Okay, so if Q is a constant, okay, and the potential is decreased and the energy stored in, if the potential get decreased, if potential get decreased and the capacitance get increased, okay, it will affect the energy also, because the equation for energy is half CV square. If V get decreased, the V square also get decreased, so the E also, energy also get decreased, but the C is increasing. Okay, so option 4 is the correct answer. So we can move to the seventh question. A proton moves with a velocity. So I think we have to write the charge of proton. Charge is 1.6 into 10 raised to minus 19. It's the same charge of electron, but it is positive charge. And velocity is given as 5 into 10 raised to 6 j. That means along the y axis through the uniform electric field. E is given. E is 4 into 10 raised to 6 2i plus 0.2 j plus 0.1 k volt per meter. Okay, and the uniform magnetic field B is given as 0.2 into I plus 0.2 j plus k Tesla. Okay, the approximate net force acting on the proton. So actually there is a velocity, actually there is an electric field, and there is a magnetic field. So what is the equation for force when there is a magnetic field, electric field? F is equal to Q into E plus that means the force given by the electric field, and force given by the magnetic field is V cross B. Okay, since E has a direction and B has a direction, V has a direction, velocity has a direction. So we want to take V cross B, that means the cross product between velocity and magnetic field. V cross B is equal to the cross product. So we can leave the magnitude 0.2 and 4 into 10 raised to 6. Just take the cross product I, j, k, and velocity. We can leave this magnitude, only consider this j. V is only along the j, so 1 for j and 0 for I and 0 for k, and B is along I, j, k, and I is 1, and see I is 1 and j is 0.2, 0.2, and k is 1. Okay, what is the result? I into 1 into 1 is 1 minus 0, so I into 1 minus j into 0. Actually we can cut, these are two zeros, so 0 into 0 into 1 is 0, 0 into 1 is 0, so j into 0 plus k into, okay, we can leave these two columns, and 0 into 0.2 is 0 and minus 1. So V cross B is I minus k. Okay, V cross B is I minus k, and what is E? V cross B. The magnitude is 5 into 10 raised to 6 and 0.2. So 0.2 into 5 is 1. So 1 into 10 raised to 6 is 10 raised to 6. So F is equal to Q into, what is E? Electric field is 4 into 10 raised to 6. 4 into 10 raised to 6 into, the direction is 2i plus 0.2 j plus 0.1 k plus V cross B. V cross B is I minus k with a magnitude V cross B. 0.2 into 5 is 1, 1 into 10 raised to 6 is 10 raised to 6. So 10 raised to 6 into I minus k. Okay, we can multiply these quantities, is equal to Q into 2 into 4 is 8, 8 into 10 raised to 6 I plus 0.2 into 4 is 2 into 4 is 8, so 0.8 into 10 raised to 6 j plus 4 into 0.1 is 0.4, 0.4 into 10 raised to 6 k plus 10 raised to 6 I minus 10 raised to 6 k. Okay, so we can add these quantities Q into, so Q into 8 into the I quantities. Which are the I quantities? We have two I quantities, 8 into 10 raised to 6 I and 10 raised to 6. So 9 into 10 raised to 6. 9 into 10 raised to 6 I plus, which are the j quantities? Only one j quantity is 0.8 into 10 raised to 6 j. Okay, and k quantities is 0.4 minus 1. 0.4 minus 1 is 0.06. 0.6 into 10 raised to 6 k. So in these all quantities we can take 10 raised to 6 to the outside. Okay, and what is q? Q is nothing but 1.6 into 10 raised to minus 90. That is multiplied by 10 raised to 6. So 1.6 into 10 raised to minus 30 inside the bracket 9i plus 0.8j minus 0.6k. Okay, so we can compare our answer with the here only we have only the magnitude. So we want to take the magnitude of a vector is root of x square plus y square plus z square. Okay, so 1.6 into 10 raised to minus 13 into root of 81 plus square of 0.8 is 0.64 plus 0.6 is 0.36. Okay, 0.64 plus 0.36 is 1. So 81 plus 1 is 82. So root 82 is approximately 9.1. So 09. Okay, so it is multiplied 1.6 into 9 into 10 raised to minus 13, which is approximately for 5 plus 9 is 14 into 10 raised to 1.4 into 10 raised to minus 12 is the approximated value. Here the first option we can change, we can't change the first option. The second option we can change to 2 into 10 raised to minus 12, and the last option is 2.5 into 10 raised to minus 12, and no another option we can change, no another options. The first option, if we want our answer in 10 raised to minus 3, we can change our answer, which is 14 into 10 raised to minus 13. Okay, our magnitude is 14. Okay, 14 is very nearer to 20. So option 2 is the correct answer. So what's the reason for the change in magnitude? Is the change in magnitude is by taking the exact root and multiplication with. Okay, you want to do the multiplication and exact root by pen and paper method, by calculation. Then we get the accurate value. Okay, this value is an approximated value. Okay, that is why the change in the answer, a minute change of 6. Okay, our answer is 14 into 10 raised to minus 13, and the accurate value is 20 into 10 raised to minus 13. Okay, this is the correct answer. Okay, we can do the problem like this in the exam. Okay, and then we can choose the answer, which answer is more nearer to our answer, so the error will be less. So we can choose the answer like that also. Okay, so option 2 is the correct answer.